Ladies and gentlemen, please welcome to the stage Josh Mook, engineering leader at GE Additive.
Thank you very much. So my name is Josh Mook. I'm at GE Additive, and some of you may not know what GE Additive is, and that's completely acceptable. We're one of the newest businesses of GE. We're only about a year old, just getting ready to pass our first birthday, so that's a big deal for us. But we are a completely separate industry vertical inside of GE. So we have about 8 verticals, additive being one of them. And so I'm going to explain a little bit about our journey and kind of how we've used this, not only the technology, the additive manufacturing technology, but also this design thinking, this kind of crowdsourcing approach to really accelerate business outcomes for us. And so I'll talk about that some today. So first of all, I want to introduce you to additive manufacturing. And so I have kind of a yin and yang here. So the left-hand side of this chart, this is traditional manufacturing. If you've ever had castings or you've ever had forgings or any of those processes, they're hot, they're dirty, they're nasty, they're a lot of times expensive, they're slow, and in today's world of rapid innovation, slow kills, right? And additive is exactly the opposite. It's on the right-hand side of this chart. It's clean, it's quick, it's new, it's efficient, it's energy efficient in comparison, and it allows us to do all kinds of things that we haven't done before. And what I like to say, if anybody in this audience, represents the left-hand side, you're either going to innovate or you're going to die, because the left-hand side of the chart is not going to be around 10 years from now. It just isn't. The new technology, additive manufacturing, or some people call it 3D printing, is really taking over. And so I want to show you a little bit about what is additive, or like I said, some people may call it 3D printing. So I've got a little video to explain it, and then I really want to take you on a journey that we've gone through over the last year, but really is just the tip of the iceberg for us, and we're going to continue to go down for the years to come.
What is additive manufacturing? Additive manufacturing, also known as 3D printing, is a process that creates a physical object from a digital design. An engineer designs the object using computer-aided design, or CAD software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins once an extremely thin layer of metal powder is spread across the platform. A heat source, such as laser or electron beam, then melts the first layer of the 3D design. The platform is lowered, and another layer of metal powder is spread across the platform. The layering and melting process is then repeated until the part is complete. The metallic powder is removed, and a physical object is revealed. Additive manufacturing allows you to produce parts that are lighter, stronger, and more durable than traditionally made parts. Build times are faster. Engineers can add precise features and complex geometries without increasing cost. In fact, additive manufacturing is revolutionizing the way we work.
So that's kind of, thanks. So that's additive 101. Right? And so it really was 4-step process. We're going to simplify it way down because we don't need to get into electron beams or the collimation of lasers, things like that, right? We really just want to focus on the 4 fundamentals. We're going to design it digitally. We're then going to translate that into some instructions, basically the Lego blocks. When we hire new engineers, we literally make them go through a training exercise where we say, build anything you want, but it has to be out of Legos, and you have to abide by this rule of layer-wise manufacturing. It's amazing how much that changes the way you think about a problem when you change your perspective on how you design. So we slice it, we print it, which is kind of, it's the heart of the process, but really we're going to kind of skip past that because I really want to focus on the innovation aspect. And then finally, we have the final part and services, and we do this all on this bed called Predix, which is our big data system where we can go get useful insights, analytics, get smarter, faster, help our customers with their outcomes. And so imagine that you're an engineer inside of our group, and we're really responsible for innovating our products and our customers' products using this brand new design and manufacturing methodology. So now as an engineer in this group, in the old world, you would design, and you would probably spend a lot of time designing because it was going to be very expensive to manufacture, it was going to take a long time, and forget about go-to-market, that was probably years down the road. Now you can design it, you can manufacture it overnight a lot of times, and you can test it the very next day. Sometimes in the week after, you can have it in your customer's hands, maybe even flying on an airplane, for an example. So that has completely revolutionized the way we think about innovation and has made it such that now the big players like GE are at risk, right? Anybody can come in, even in complicated spaces like aerospace, and disrupt us. So what we did is we established a team, which is our innovation teams, purely to disrupt ourselves. That's all we do. We've got about 100 people now. All we do is disrupt GE every single day. And also getting great outcomes from that help the bottom line. So why would we use additive manufacturing anyway? This is a question I often get. And we're really going to break it down into 3 elements. One element is that it expands what's possible. I told you that you can now innovate the big players. No one is safe. We like to say additive is here when we're talking to customers. You're either going to be a leader in this technology, adopt it, lead the way, or you're going to be a victim to this technology. And that is the reality a lot of times with technologies such as this. We really truly see it as the next industrial revolution, and it's happening right now. What a cool time to be alive to watch this happen right in front of our eyes. But it expands what's possible. Products that before engineers would have said you couldn't do, it was too expensive, it couldn't be made, you couldn't make money off of it, now are back on the table. It improves quality, and if you ever fly on an airplane, I came from aviation, doing jet engine design, and so I'm really happy every time I get on that the quality level is improving every day into the parts that we make, which is making our components last longer, giving our customers better outcome. It also simplifies systems. I could take what used to be a very complex system and simplify it down into a single element. This is what allows us to go fast and to really disrupt ourselves. So I'm going to give you a couple of case studies, and then I'm going to go show you how we spread this through our whole organization. So first case study. This is the very first part that ever made it into revenue service in aerospace that was additively manufactured. It's a fuel injector. So this is essentially what atomizes the fuel in a jet engine, prepares it for combustion, and essentially powers the whole airplane. These are flying today, by the way. Some of you that traveled here, there's very possible you could have flown on an airplane that has 3D printed parts powering your airplane. In fact, they're the only source of power to the airplane because all the fuel gets injected through them. So sometimes that scares people. To me, it's very exciting. Especially this part. I had the pleasure of designing this part back in the 2011 timeframe. And innovation is one of those things that consumes you. In fact, my wife says that this is our 4th child. We have 3 actual children. But that's just what innovation does, right? And this is no different. But let me give you some statistics here, right? So this part used to be 20 components. It's now 1, right? It's a very complex part. I wish I could kind of give you the details of the interior, but you just have to trust me. It's very complicated. It's about 5 times more durable than what it was in the past. So if you think about driving customer outcomes, if you have your automobile, which most of us have, and you think about something that you have to replace on a regular basis, what if you could wait 5 of those intervals to replace it? That's going to help your bottom line as a customer, so we're providing immediate value to them. It's also a 25% weight reduction, which in aerospace is everything, right? For grams, we will fight for grams of weight in aerospace. 30% cost improvement, that's always good, right? Cost of goods sold going down for better performance, that's a great thing. But here's the one that we didn't, I don't think, anticipate, but with on-demand manufacturing, we actually went from 100% inventory to 5%. So we were able to take warehouses full of non-usable cash and free those back up, right? We can now reinvest that and move forward even faster. So that was our first example. A key thing we learned in this was with additive manufacturing, as design sophistication increases, the cost actually goes down, which is completely inverse to the way that the world was previously. If you think about that red line in the lower right-hand chart, this was the world that engineers lived in. As they made something more complex, the cost went up. It used to be, for a simple part, it was cheap. For a complex part, it was extremely expensive. This is usually some sort of exponential scale. But now the exact opposite is true. You're going to have this buy-in cost with additive. It is a relatively high technology still. So for simple parts, it's very expensive. As we actually add sophistication to it and remove material, it gets cheaper. Don't forget, you're only paying for the material that you keep. There's essentially no waste in the process. It's really cool. That was a big, big mind shift for us. And there's an industry that it has really impacted. One of this is medical implants. So we work on medical implants. What you're seeing here is essentially a hip cup, okay? A hip cup, the way they used to be made is they were machined out of a huge block of metal, throw more than half of that material away. You would then try to put some coatings on it or other things that would help it adhere to the bone and have your body work with that. But generally it had relatively low success rates. Because additive manufacturing doesn't have any sort of penalty for complexity, we were now actually able to learn from nature. Nature had figured out how to make bones work, mimic that shape, and your bone actually grows into that implant now and it becomes part of your body. The success rate is nearly 100%. So if anybody in this room ever has to go get an implant, you're probably going to get a scan. They're going to design that custom to your body, and then potentially in a couple days, maybe a week following, you're going to have that implant and it's perfect fit to you. That is a complete shift in the industry. And has really helped people get back to their normal life in a very, very quick way. Another example, this is, again, back in aviation. That's where I came from. So this is what we call the advanced turboprop engine. It's relatively small. If you think about it, it's about this long, and it's around 2,000 shaft horsepower, so pretty power-dense machine. It flies propeller aircraft, relatively expensive propeller aircraft, things that businessmen or women would have if they're doing pretty well. Not me, unfortunately. But we decided, well, what could we do if we revolutionize a product? I mean, GE's been making jet engines for a long time. We kind of know what we're doing. But what if? What could be possible? So what we did is we set aside a team of about 8 people. So this is 8 people, small team. We could set up a whole bunch of these teams here in this room. And we gave them 18 months. And we said in 18 months, with this new design and manufacturing technology, see if you can actually upset the entire industry. That's a pretty big ask, but the team was excited. These are our entrepreneurs at heart, and they were ready to go. At the end of 18 months, we actually tested the engine, so it wasn't a paper design. We actually built it, designed it, built it, tested it. And now we're bringing it to market. And basically, in about 18 months, we're bringing a brand new, never before seen product to market in aviation. That's unheard of. At the same time, we're able to reduce the weight of the product by 5%, which is a big deal to the airplane. We're able to take 855 parts out of that engine bill of materials. Essentially, imagine taking 855 parts, setting them on the side, taking 12 additive parts, putting them back in, and the engine is complete. That's how transformational it is. And we get about 20% fuel burn improvement to this engine enabled by this new technology. 20% fuel burn to any of us in our daily driver is a big deal, but especially in an aircraft engine where the fuel is very expensive, where the distances are usually long. Big, big disruption. The really cool thing about this is we had not participated in small engines for quite a long time. In fact, GE had made the decision we were really going to participate in the big engines, the stuff that takes billions and billions of dollars to design and develop, and we're going to go after those. So we had been out of this space for a long time. Now we have sole source contracts on an airframer because of what we were able to do with this technology. Big, big mind shift that's changed the competitive landscape for small engines forever. Let me give you another example because we talk about kind of the power from a design standpoint. Let's talk about from an enterprise perspective. So here's an example of one part. On the left-hand side, the top 3 bubbles is kind of the additive. The bottom 3 is what we call subtractive. So we call everything that's not additive or 3D printing subtractive. It makes it sound worse, bad. So we had a part in there that used to be 300 components. We call it the midframe. It's kind of the thorax of the engine. It's a really, really important part. It's where all the combustion happens, all the power is generated. It used to be 300 individual components. It's now one part. It used to take 60 engineers to design that, and now it takes 8. engineers, because they used to have all these 300 components, needed their own supply chain. They needed negotiations, they needed drawings issued, they needed engineering, stress, life, aerodynamics, etc. Now I've got system thinkers that are thinking about that all as one piece. I used to have 50 different manufacturers. Each of those manufacturing contracts had to be negotiated. There had to be audits. I mean, we're running aerospace quality is a huge expense to the enterprise to keep 50 manufacturers up and running. Now I need one. I need a machine, and it takes me about 20 days to manufacture one, where it used to take me 8 months to procure it. In addition, I need only one service shop to service these. I have one data source of the truth, which is extremely important, especially when you're trying to go back and identify some problem, let's say, that's in the field, for example. Has completely changed our enterprise well beyond the initial thought of what can it do to products, or what can it do to outcomes just in our small world of like cost of goods sold, for example. So a little bit about our journey. So you'll see a couple of those elements on the journey, and I'm not gonna get stuck on these, but what you see is we kind of started small, we grew. You see the advanced turboprop there on the right. Things were going great. On the bottom hand of this chart, we were growing our infrastructure. We'd acquired a couple companies. We're getting pretty serious about it. Last year, about this time, we decided we were gonna form a brand new business called GE Additive. We thought our position was unique, acquired a couple of manufacturing companies, spent a few $1 billion on really growing this out and making sure we are gonna be leaders in this space. So then what we said is, well, what's next? We've done some great things, and they're really helping us grow. But what are we gonna do next? So what we did is we set a goal for ourselves, just like everybody does. We said in less than 10 years, we're gonna drive $5 billion of cost productivity inside of GE. So $5 billion, 10 years. It's a pretty big goal. Didn't have a very big team to execute it. Luckily, GE is 330,000 people. So do have a great extended team, or bench, as some people may call it. But we had to go exercise that, and we had to go move the needle. So I'm an engineer, so let's break this down. So if I break it down, $5 billion, it's $500 million a year, 41 million a month, you get it. It works down to $16 per second. I don't know about you guys, but the last second I was just speaking, I did not save $16. But that's what we're asking our engineering team to do. And so we quickly realized that this was something that was going to be monumental, and to hit these type of targets, we're going to have to think differently. The old way to approach problems wasn't going to work. So the basic question was how? How are we going to pull this off? So this is really the start of our journey from kind of, an innovation, an open innovation process. So luckily, GE being a pretty vast network that we are, we used what's called our Genius Link team. And our Genius Link team is part of our global operations, and they're really focused every day on crowd powering the future of work. They're really connecting it's just in the title, connecting the geniuses, right? Connect them to the right people. So what we said is we need help. We've got 50 engineers. We're responsible for $5 billion in 10 years. And by the way, this is not $5 billion of new revenue. I actually think that's easier. This is $5 billion of cost out, which engineers have already been working on. So you have to go in to something an engineer's already been working on for maybe half their career in some cases, and say, I'm gonna do that better than you can do it, and I'm gonna save more money. And so what we did is we quickly realized that, listen, the world is changing. The old day of an engineer sitting down and working on something and perfecting it and moving it out isn't gonna work anymore. We need everybody. And we talked about this earlier, the speed of innovation is changing, right? When we were looking at Moore's Law, that's exactly where we are right now in manufacturing technology. We are seeing the first Moore's Law period in manufacturing, which is really, really cool. You haven't seen this type of acceleration since the last industrial revolution. And so once we kind of embraced, the 7 steps, once we came to the conclusion we can't do it all, we started to engage the team, and our Genius Link folks helped us do that, and some of them are here today. And so what we realized is we've got to integrate the crowd, and AI. We've got to use all these tools. We call it the GE Store. We have this huge storefront of people and experts and tools, and how do we use those all to our favor? How do we start to be very predictive instead of reactive? How do we really optimize our daily work and minimize time spent? And that's what we focused on. So at the end of the day, you've got some of the GE businesses at the top. You've got me down at the bottom in additive. And we've got this Genius Link group here in the middle drawing us, connecting us. So we're obviously using some of the Bright Idea tool suites, but also many layers on top of that, including communication platforms, marketing platforms. How do we make sure that every single one of those 330,000 people inside our company knows that we respect their ideas and we need them to meet our goals? And in some cases, I can offer them very little in return, right? But for a lot of people, at least what we found inside our company, is most people have these pin-up ideas. They just need an outlet to get them out in the open and someone who can cultivate them and move them on. So we had that. So our additive team was about 50 folks that were purely responsible for cultivating these ideas and executing on them. So where did we end up? So here's the results. So you heard today, at the time that we started preparing this, we were around 2.2 billion. I'm happy to say now we're almost at an audited 5 billion. By the close of the year, we'll be over $5 billion across that. So, we're going to raise our numbers. Basically, that's what's going to happen. But that's okay. The team has accelerated. They now know what's possible. Before we would have said that, maybe this wasn't possible, but to do 5 billion in 9 months, this is a huge, huge result. We have over 150 committed projects. So this doesn't mean just thoughts or ideas. These are actually products that the business is pouring money into to commit using that manufacturing technology that we talked about. Completed well over 200 prototypes, well over 400 patent filings in the last 9 months, which is really securing our position in this space. We're working across every industry, even industries that GE doesn't offer product in, because that's how revolutionary this technology is. And many, many component tests to prove that we know what we're doing. Right now, we actually have a different problem. We have a problem of backlog. We have over 1,000 good ideas. These are the ones that have already been triaged for the stuff that's like, go print, everything. To probably actually legitimate ideas, we have over 1,000 of those in backlog. We've grown our team of just the people who curate those to 100. And we're continuing to execute those because the return on investment is there. Driven new materials. There's new materials that exist today that didn't exist 9 months ago because we have people in a manufacturing shop that saw a need, right? And then our material sciences folks were able to connect to and drive those. New machines that we're offering now for sale. New applications and spaces that before we didn't even compete in. Well over 3,000 members involved. We actually have about 150 sites that have engaged globally on our project. And like I said, about 2,200 really, really active users, and this is growing every day. So if nothing else, I didn't have any tips or tricks, so to speak, but just wanted to come and give what I hope to be a success story and let you know that these audacious goals are possible. We like to say we're going to set our moonshot, right? So I can't wait to see what next year is. That 5 billion was supposed to take us 10 years to complete. We essentially have the pipeline filled now in 9 months. Now we have to go execute, right? If there's one thing that a company like General Electric's great at, it's execution. And so we're going to go now do that over the next 5-10 years to get those into product. But we're just getting started, and we're really excited to continue down this journey and leverage the power of the crowd and hopefully even work with some of you as we move forward. Thank you.
Woo! Hey, Josh. Thanks. Awesome presentation.
Absolutely.
I don't think anyone's going to accuse you of thinking small. That's for damn sure. There's so many ways to attack this. On the one hand, you're an entrepreneur like Eric was talking about. On the other hand, there's this actual process you're running with the crowd and all that stuff. So, and at the broadest level, you're at ground zero of disruption, disruption of industries. And I think the reason I thank you for coming, I know you're in some ways one step removed from us because we work primarily with Genius Link, but I just wanted this community to see disruption in the face of it, right? And I think you tell that story better than anyone else I know.
Thank you.
So where do we start? I'll start with my boring question that has interesting answers. Where did you come from? You're an engineer. How did you find the scent of this additive stuff and get on that track?
Yeah, so my background, I'm an engineer, like you said. I was trained as an aerospace engineer, so I had spent most of my career, the first 12 years of my career at least, designing jet engine components. So I was kind of, an aviation geek, so to speak. Really love that. Also a private pilot, so it's kind of in my blood,
cool.
right? That's what pursues me. But the really nice thing that I think set me up well for this kind of internal innovation is in aviation, innovation is everything. Meaning, there is no such thing as a commodity in the aviation market. It's all about how can you be better than the competition? How can you have better fuel burn, better durability? Passenger safety is our number one. That's something that we would never ever waver on, and that's really important. And so inside of growing up as an engineer inside of a group like that, really what you find is innovation becomes part of your blood and just becomes part of your process. And so then to be able to take that into industries where maybe they've lost that over time is really exciting and best thing about my day.
Sure. Now, to a lot of people, they hear 3D printer and they think of something that makes a little plastic chess toy or chess piece or something like that. So, were you guys tinkering with 3D printers in the aerospace or aviation group, and then sort of somebody saw that you could actually make production parts with it, or
that's exactly what happened. Yeah, so we had been working in it from a pretty serious material science perspective since the early 90s. And it kind of graduated from science to engineering somewhere in around 2010 timeframe when we committed a project to it. Because finally we had gotten the materials, we had gotten the science where it needed to be to take it to the next level. That's where I got my start in the technology. I got the luxury to lead that first fuel injector program. Was our very first FAA certified component. And to say your first component is going to have to be certified by a regulatory agency, is going to have to fly people every day, and at the end of the day, I had to sign off on that, right? That's okay to do so. That's not an easy one to start with, but I think that's really what put us in the best position. I think if we would have started small, we would be very far back on our journey. So what we said is, no, we're going to commit this technology because we see the potential. We see the vision to something big, and then we burn the boats. We had no backup plan. I think that's another big thing. And just to give you a calibration on how big of a bet this was in hindsight, if this one component would have failed in this engine, which is called the LEAP engine, it's our most successful engine, will be to date. If it would have fell flat on its face and we wouldn't have been able to execute that program, there was enough tied up in that it could have bankrupted the entire GE company. Oh, man. And yet we were able to do that with no backup. Because that's what it takes. That's why we equate it to the moonshot, right? There is no alternative. You have to make it work, and that's what it took for us to really say there is no ripcord we can pull. We're gonna figure this out.
I'm interested in the sort of the organizational dynamic. So you're there in is it aerospace or aviation? What do I call that box?
Whatever you like.
Okay. So you're there in aviation, and then the stuff is sort of bubbling up, and for a lot of people, a growth program that becomes a whole new business unit, especially at GE scale, is like the holy grail. Like,
right.
People would love to find those seedlings growing up. Yep. And I'm just curious what, to whatever extent you can replay the tape on that. And was it just like, let's try this? Or was it like once you had that first fuel injector, like the light bulb went off, or what?
So I think something we probably didn't recognize then that we truly understand better now, and Eric talked about it, is when we had that great success, we basically generated a bunch of entrepreneurs. And what we did is we continued to water those and to foster their development. And what that quickly grew into was this eagerness to disrupt everything that we touch, right? How can we, really change the game on every industry? And so it almost became something that was consuming to the team and just excites them and ignites them to come in every day and move forward. And so that's what we've been able to grow. And we've grown that well over, now we've got about 2,000-3,000 people trained inside the organization in this same kind of methodology. And just to see what the power of that is amazing.
What I know you guys did some acquisitions, but initially was it was the additive technology homegrown, or were you using third-party printers, or what's the layout of that?
Both, yeah, both. So we home grew a lot of the technology, which we needed to do to advance the state of the art. We were also using technology that came from industry, but what happened was the same thing we were doing inside of our own industry segments. We decided we needed to do to the machine manufacturers themselves, meaning we were out innovating the machine manufacturer on the additive machine. So we decided to spend a couple $1 billion there, make some acquisitions, and really revolutionize that product line as well. And we're unveiling some new products here this year that are going to be quite disruptive in that space.
So the benefits are pretty clear. I mean, these things that come out the other side are sort of better in every way, lighter, more efficient,
Yep.
more durable. How for an uninitiated person like myself, how much work goes into, redesigning that? Or I assume you need some wizards or some ninjas, but and maybe it's like having a fourth baby, but but just give us some high level of because I have no idea what's required.
So that is the single biggest barrier to the technology, is how do you reinvent your product? So, you can imagine, especially a space like aviation that's built on a lot of industrial know-how and kind of institutional knowledge, to be able to go in and say, we're going to change this and the way it's done from the way it's been done for a pretty long time. And so that's our number one hurdle. And so really the proof is in the pudding. When you can go demonstrate and execute a test, for example, that demonstrates it, or you can go show that you can realize goals that were previously thought impossible, that's how we've done it. And so that's why we have a team of around 100 people that are essentially curating these ideas. What I mean by that is they're not managing tools or the back end, so to speak. They're actually the ones prototyping and executing and failing. We fail a lot. We don't talk about those, but we fail a lot, right? What we like to say is fail when it doesn't matter.
Sure.
Right? And so usually not in front of a customer, for example. That's usually a bad time to fail. But we do it a lot, and we reward it, and the people are just addicted to that culture. And so we've found the folks inside the organization, as well as the ones that want to come be part of that are addicted to that as well, and they're the ones that fit into the family.
Awesome. So I had another thought. I want to bring some context for the Bright Idea folks here. So like Genius Link came, enabled the crowd, and you guys are basically managing a pipeline and sort of vetting things early on, and tracking some financials. So maybe just share some color around that because this is inside baseball for this group.
Yeah.
But what capabilities are you using to sort of enable this process?
Yeah, so we rely very heavily on our global ops and our Genius Link team to make sure we're on the right path, right? And so I think that's where it becomes a really nice relationship, also with the team at Bright Idea on new feature and enhancements and things like that. But essentially, if you think about how does it work from an inside the organization standpoint, we need all of our engineers focused on engineering, right? Not on management of the tools, not on database management, things like that. And that's where our Genius Link team comes in. And they make sure we're getting to the right people. We're releasing the statements and the press releases, internal or external. We're releasing, the tools are always being where they need to be. The platform is ready. And so they do all the heavy lifting, so to speak. We kind of have the easy job on that side of it. And then just get to reap the benefits of all those ideas. One of our biggest ideas came from someone who runs a lathe on a shop floor in Erie, Pennsylvania. He had no voice.
That's awesome.
But now he has a voice, right? And he has people that can take that and make that happen. And so that's I love to see those stories.
Yeah, that's awesome. I know you guys, I don't want to get into anything too proprietary, but I know you guys have actually taken data about what's successful and looked back and sort of targeted your efforts. So can you talk to that at all?
Yeah, so not only are we trying to innovate our products and our customers' products, but we also design and sell equipment, this additive manufacturing equipment. And one of the really important things as a product, someone who makes a product, is we need to know what that next product needs to be. We need to know what our customers want, et cetera. So that's another thing we're able to do in the platform is we gather all this data about business cases and maybe ones that didn't quite make the cut. We've got plenty of those. But what we're doing is getting smarter on what materials need to be enabled, what business case just almost made it, but we need another leap in technology to get it over the finish line. And we're able to digest that and consolidate that to drive our next product portfolio. So we're actually now releasing products as soon as next month will be our first new product release that is built off of customer feedback directly through the ideas that they submitted, which is really exciting.
That's awesome. What about, again, going back to sort of organizational dynamics, I'm curious, this thing starts, snowball rolling down the hill, building momentum, and then are you going to the board to like pitch some of this stuff, or, what did the additive team have to do to, like I said earlier, people would love to create a whole new business unit with the growth potential that you guys have created there. And I'm just curious how that thing sort of matriculated up and you got the resources you needed.
Yeah, absolutely. So, certainly the board has to be involved all the way up, to our CEO and get that buy-in. But really the way we did it is through showing. Right, so there wasn't a lot of convincing that needs to be done. When you can bring someone in, they understand what a product used to look like, and you can literally lay down on the desk a product that looks different and explain the benefits. So that makes our life pretty easy, right? It's usually a quick invite, say, look at these revolutionary things that we've done. This is what it's going to do to our bottom line, to our business. The rest is simple, right? And so that's really how we've executed it.
I just want to take a moment, to say, I think Jeff Immelt did a tremendous job in terms of charting a course for this company that basically won the 20th century, and he put chips on the board in superb places to set it up for the future. So maybe we just give him a hand here. Just a really special leadership team that is there.
Take some big bets and wasn't afraid to do so.
Yeah, and that's hard to do. I know we're getting a little short on time. I want to kind of zoom out to the broader picture of disruption and transformation. I consider myself an innovative person. I consider myself, embracing change, excited about change. But the numbers you put up are almost scary. They're so staggering.
Yep.
So what, if anything, can you tell us about what it's like to be at the eye of the storm of disruption and like? I love the simplicity where you're like, oh, just put the thing down on the thing and it passed quality assurance. So why not do it?
Yeah.
But how do you help people over that fear factor, or what does it feel like to be at the center of that storm?
Yeah. So it really, I've certainly never worked at a place that's like this by any means, where we can literally think of ideas or innovation in any space, and then be able to go execute that. Rarely does that happen. And to do so with the resources of a GE is really the combination that makes that happen, right? None of the folks on my team ever have to worry about money, right? If they need funding to go do something, they go do it, right? And so I think it's that combination of trust that these folks that we've built up, that are these entrepreneurs that are just hungry for disruption, trusting that they're going to be good stewards of the organization and of the technology and of the resources, and then just let it happen, right? And so it's kind of just, I think every day within our organization in Cincinnati is not too different than every day in an organization that I see out here a lot, where it's crazy, it's chaos. Right? There's no such thing as a schedule or a product plan or anything, right? It's just gas, but in a kind of a beautiful way that's just moving so fast that if we took the time to even create a schedule, we should have just done it, right? And that's really what's changed. And some people can embrace that and some can't. And the key is making sure we have an organization of people that can handle that kind of place.
Yep. Quick side note, we're going to be talking about a new app that's based on digital transformation and sets up a similar process where you can sort of crowdsource opportunities. It may not be for additive printing, but it might be just applying digital to an analog process. So I just want to say thank you for coming and sharing your story with here, and congratulations for all your success. And I'm looking for what your big, hairy, audacious goals are going to be for next
For
year.
next year. All right. Thank you.
Thanks.